Hello everybody. I'd like to welcome to all to the sessions where we are going to discuss about this topic electrical resistance thermometers, right? I am Subhrajit Sahu, assistant professor in Emerit Engineering College. In this video, I will discuss the several types of electrical resistance thermometer. In the last video, I have covered what is the working principle of this kind of thermometers, and I've given some introduction about some electrical circuit like Wheatstone bridge circuit, how it is working and how it is useful for measurement of temperature also, that I told in the last video. Today I will do the discussion on electrical resistance thermometer, right? Sir, electrical resistance thermometer, in this category there are several types of temperature measuring instruments are available. Based on your syllabus, we are going to discuss only two types. One is thermistor, second one is thermocouple. This electrical type, two electrical type temperature measuring instruments we are going to discuss. Today I will tell about this thermistor. No? Thermistor. It has several applications, right? This thermistor generally used in several applications. Nowadays, the digital thermometer is coming, right? Digital thermometers here. This one digital thermometer is coming where thermistor is used. Okay, later I will tell about all these applications. Now this is the diagram of this thermistor, how it is looks like this is a very small component. It is not a very big component, actually small components. So it may be, now it is a disc type, maybe circular type, maybe rectangular type, any shape of this one it can be available, right? Just I have collected this picture from the internet. So it is the thermistor. And interestingly, here written two things. Observe. One is NTC, another is PTC. What is this one, sir? NTC stands for negative temperature coefficient, right? Negative temperature coefficient. And PTC stands for positive coefficient of temperature. Positive coefficient of temperature. So what is the meaning, sir? Meaning is very simple. That means whenever the temperature increases, the resistance of the material it decreases. Whenever the temperature increases, the resistance of the material decreases in case of negative temperature coefficient type thermistor. And in the case of PTC type, positive temperature coefficient type, whenever the temperature increases, resistance also increases, right? But widely this very familiar, this one. Most of the cases this type is used. This one is rare, very rare. This one, some special cases where you can go for the PTC. Otherwise, in everywhere we'll find the negative temperature coefficient thermistor, right? Very simple constructions. Okay, these are called lead. Where is that? These are called lead. And this is the sensing element, temperature sensing element, sensing ball, we can say sensing element. Okay, we will expose this portion where temperature is to be measured. Simply we will keep this one, this end where temperature has to be measured, we will keep, right? This is the lead or where, right? So it is NTC and PTC, sir. As I told, what is the working principle of this one? Very simple, sir. Working principle is, working principle is when the temperature is increased, right, or increases, then what happen? The resistance of the material will be vary. The resistance of the material will be vary, right? Vary. When the temperature of the material will be increases, the electrical property resistance of a particular material will be vary. Sir, what are those kind of materials? I will tell you, don't worry. What are those kind? Can we use every materials? No, we cannot use every materials. Some specific materials is available in the nature. Already that has been tested by the scientists. All the properties have been listed out, and that suitable materials we will use for thermistor constructions or for the measurement of temperature purpose, right? What are those materials? I will tell you. Sir, what is the principle? Principle is very simple. Whenever temperature increases, the electrical property, which one? Resistance of the material will be changed, either increase or decrease. Just I told you. Some of the materials, when temperature increases, resistance decreases. That is called negative temperature coefficient that material having. And some of the materials, temperature increases, resistance also increases. That is called positive temperature coefficient of materials, right? Those two concept is used to construct this thermistor, right? This thermistor. Okay. Now I will tell the thermistor constructions. Very beautiful constructions. Observe here carefully. Now, as I told, we will take a Wheatstone bridge circuit. Okay. Wheatstone bridge circuit for measurement purpose, for the measurement of that current deflections we can use here. We can use the Wheatstone bridge circuit. This is a galvanometer, galvanometer, right? And you see, this is the thermistor here. I connected NTC type, and it is kept in a tubes because this is very thin. I mean, this is very not so strong actually. Very small, thin wire is there, and this is a disc type head is there, so it may break. So it should be kept inside a tube, metallic tube. We can say it is a metallic tube, right? Now this is the simple construction. So what happened in the Wheatstone bridge circuit? I told this was R1 I had taken. This is R2. This is R3, and this is R4 I had taken. Right here, in place of R1, we are connected what? In place of R1, we are connected this thermistor, right? We are connected this thermistor, and remaining three resistance are there as it is, right? R1 is not there, so in place of R1, we have connected this thermistor. Now R2, R3, R4 is there. Now here we are going to supply what? Direct current, right? Direct current. I mean, it will not take any instruments of this. Electrical type measuring instruments. They will never take the alternating current. Always they will take the direct current, right? But generally we are connecting to the alternating current source. But within that device, some changes is happening by the suitable arrangement, right? Now, see, observe, sir. Now this is the constructions. I told what I told. This is the constructions, right? One of the arm of the Wheatstone bridge circuit is connected to the thermistors. Now, what is the working, sir? How it is working? Thermistor, this end I will keep where temperature is to be measured. Where temperature is to be measured. Okay, I'll keep this one. I'll keep this one where temperature has to be measured, right? Suppose the temperature is anything, hot area, very hot area, 70 degree, 80 degrees Celsius. I will keep this one. Okay, I'll keep this one. So, and here I'll supply a constant current here. I'll supply a constant current. Direct voltage I'll supply here. So now, two cases I will tell, two situations I will tell here. For working, it is most important, two situations. What are the situations, sir? When the thermistor is at a normal temperature, atmospheric temperature, normal temperature, no heating is there. It is not comes in contact with any heating material, any heating regions, only simple normal temperatures. And I am supplying the here direct current. At that time, you assume this Wheatstone bridge circuit is balanced. If it is not balanced, we can make it balanced. This is a variable resistance, right? We can make it balanced anyway. The galvanometer will show the zero reading. You assume that it is balanced, right? Balance means G is showing G is showing zero deflection, null deflection, right? Now this is the first situation. When the temperature is normal temperature, G is at null position. Null position. Galvanometer is showing null positions. Now I expose this end thermistor to a region where temperature is high. Temperature is high. Okay, 70 degree, 80 degrees Celsius, whatever it may be, more than normal temperature. Temperature is high. Then what happened? Immediately the resistance of the materials, the resistance of the material will be changes. Resistance R will be changed. Okay, R will be changed. If it is a negative temperature coefficient thermistor, then R will be decreased. The resistance will be decreased. Comparison to what is in the normal temperature conditions. Now resistance decrease. If resistance will be decreased, what will happen? Again, the circuit become unbalanced. Now voltage difference will be created. The difference of voltage will be created. The circuit become unbalanced, and current will start to flow. Current will start to flow. If current will start to flow, the galvanometer will be deflect immediately. It will be deflect from the null position. Right? It will be deflect from the null position. Now, how much deflection happen here? How much deflection happen here? That is because of resistance changes. Again, resistance changes here. And why the resistance changes happen, sir? Resistance changes happen due to temperature changes, right? Due to temperature changes. Normal temperature was there earlier. Now temperature increase, resistance changes. If resistance changes, current flow here. So galvanometer deflected. So reading, right? Then that means everything indirectly the current here appear, the current appear because of this temperature change only. Okay, because of this temperature change. Then what I will do, sir, if the temperature will be more here, more current will be flow. More current will be flow. That means galvanometer will be deflect more. It will deflect more. Right? That means here there is some proportionality between temperature and current. Current signal or electrical signal. Right? So if I'll convert into a suitable calibrated scale, then I can measure what is the temperature at this particular point, right? At this particular, so just for simple example, I will give a simple example. I will give, sir, how to calculate the temperature. Suppose galvanometer is 0 ampere. It was showing earlier. Now it is shown. Now it is shown 2 ampere. Suppose, okay, 2 ampere. Now it is shown 2 ampere. So it is shown 2 ampere. Suppose temperature rise how much? For 2 ampere temperature rise, suppose 10 degrees Celsius. Right? 10 degrees Celsius. Now for 1 ampere, suppose assume temperature is 10 degrees Celsius. For 1 ampere, how much will be temperature, sir? For 1 ampere, 10 by 2. How much? 5 degrees Celsius. Suppose the galvanometer is showing here reading, suppose 15 ampere. If it is 15 ampere, then what will be the temperature, sir? 15 into 10 by 2. Okay, 150 by 2 is approximately equal to 75 degrees Celsius temperature. Like this, we can convert this current reading to temperature measurement, right? Temperature measurement. Anyway, so this is the construction and working of thermistor. Very simple, sir. Where its applications or advantages is what? Advantages is quick response. Most important is quick response. Immediately it will be response. But in the mechanical principle type thermometers, bimetallic strip, liquid in glass thermometer, their response is very slow. Response is very slow. That's why those instruments we cannot use for continuous measurement of temperatures, continuous regular measurement of temperature or continuous measurement of temperature. But this one we can use. Okay, in every medical appliances where the temperature has to be measured, this kind of technique they are used. Those mechanical type principle techniques already they are obsolete total. They're not using at all. This kind of which quick response, right? Will give quick response and accuracy is more. Its accuracy is more here. Accuracy is more. Then so this is the some advantages and very cheap cost also. It is no not very more cost, is cheap cost because this is very less cost, right? Cheap cost, right? Cheap cost. Sir, sir, what are the disadvantages here? Okay, disadvantages of this one. Disadvantages of this one. So disadvantages means in the terms of temperature range only. Temperature range only. We can say some disadvantages is there. Other than that, no such disadvantages is available. Only the temperature range. It can measure a temperature from certain range to certain range. Again, some certain range to certain range. I'll tell that range also. Don't worry. Certain range to certain range it can measure. Sir. What are the materials, sir? What are the materials is used for measurement of this temperature? Now, so for the construction of the materials, what are the temperature materials, sir? Materials are generally metal oxides. It is made up of metallic oxides, right? Metallic oxide. Metallic oxide such as chromium. You can say chromium, nickel, iron, manganese, okay, manganese, cobalt, okay, like this metallic, not pure. The oxides formation of this metal is used for construction of this thermistors. Apart from that, another types of materials also used. Semiconductor materials also used. Which one? Ceramic. Okay, ceramic material also used for construction of this thermistor. Right. I hope this topic is understand to you very much. Now I will tell about the applications, where it is used. I told glass household thermometer, right? This is a household thermometer where digital thermometer where the thermistor is used. And here in the automobile engine to measure the coolant temperature, right? To measure the coolant temperatures, this is used. The thermistor is used as a sensor to measure the coolant temperature. If the coolant will be overheat, automatically engine will be stopped. Engine will be stopped, right? Engine will be stopped. In the same case also, it is used in the air conditioner also. Air conditioners, it will sense the room temperature. This will sense the room temperature. If the room temperature reached a certain limit, automatically compressor will be off. Okay? Compressor will be. It is act as a thermal switch. Okay, thermal switch which is responsible to on the air conditioner and off the air conditioner also. When electrical switch is there to on and off, but once we on in the whole night, the compressor is not run. Based on the inside room temperature, automatically compressor is off, automatically compressor is on, which doing this thermistor sensor is doing that one. Okay. Now this is also a refrigerator. In the refrigerator also thermistor is used. Same for compressor off and on case, right? Very interestingly, mobile charger also you are using the thermistor. Mobile charger, where suppose the mobile charger is get heated, then automatically current will be cut. Current will be cut. So for a few times current will be cut and charger again will come back to its normal temperature. Also we can use in mobile also. It is also used in mobile. Mobile sometimes it is getting overheated. When it is getting overheated, this is act as a sensor. It may switch off the mobile. Okay, it may switch off the mobile, or it may close all the processing applications, or it will be stop the processing applications so that your mobile again come back to the normal temperature. So these are the several applications of the thermistor, right? I told in this video what is the construction, working principle, advantages, disadvantages, and application of the thermistors, right? The question will come. A question will come. Explain about, or with neat diagram, neat sketch, explain about thermistor type electrical resistance thermometer, right? Or thermistor, simply it can ask, right? You have to mention all this point, right? So it is a good point to stop here. So in the next video, I will discuss some new topic. I mean thermocouple, about the thermocouple I will discuss, which is very, very interesting also. And today I'll conclude here. Till then, you take care and bye.